Let's start with a very simple question. How many of you want to get hired at Google? Let me guess. I reckon majority of you would say yes, either confidently or reluctantly. And I say reluctantly because you know the difficulty of this challenge. But I have a good news for you. I can give you guarantee to succeed in at least first few rounds of Google interview if you give me guarantee of your dedication to learn this subject. Now, you will ask me how. Well, in the Google first few interview, one question is really certain. They will ask you to design an algorithm, measure its performance, and improve its efficiency. And that's exactly what the scope of this subject is. I know many of you may be thinking that this subject can be boring. And I can visualize it. You may be thinking like this. Yeah? That before attending any of the algorithm and analysis class, you may be very excited. Okay? And then afterwards, absolutely not. I don't agree. Because if you relate the contents matter of algorithms with the real world problem solving, you will find it the most exciting subject ever. And now, again you will ask me how. And here's my response. Let's get started. So let's see. You want to count the number of students in this classroom. And you want to write an algorithm. You have some sensor installed in the classroom like this. And every time your sensor detect a student, you're gonna increment. So how will you write an algorithm? Let's start. You define a variable n, initialize it with 0, and every time you get an input from your sensors, you're gonna increment it. Okay? Do you think it's an efficient way? Can you improve it? Of course. One of the easiest ways of looking at it, there are many different ways to improve it, but the easiest way can we count 2 students at a time? Yes, you can count 2 at a time. Okay, and 3 at a time and so on. So that's how you're going to improve the efficiency, and that is exactly what the approach we're going to follow in this subject. Okay, so let's have a look at another example. Like, you want to count the total marks in your exam, and you get around 10 questions. You're going to put your marks in an array, and then you're going to run a sum function. And I'm going to ask you a few questions like this. How much time it takes to run this function? Well, the answer may be easy, because you will just use the time function and you can calculate the time. Easy. What if I ask you what is the runtime of this function and how it grows? Okay, that's where the subject will come for your help. Okay, and that's what we call time complexity. And how can we show it? By some notation like big O. Okay, we also look for the space complexity and all different other kind of notations. So for this particular kind of example, how can we actually calculate it? There are many ways. The one way is to try a different number of inputs and see how much time it takes for each, and then you plot it. Once you plot it, you get this kind of a graph. The x-axis is where you get the number of inputs, and the y-axis where you get the time. So you get a linear incremental graph. Okay. Now, how can you show it? Okay, so the notation you can use big O. So you can, it's a big O of n, because it's a linear time. Okay, because it's depending on the n, which is the size of the input. Okay, now you can have other algorithms which have a constant time. Okay, and you can have some other algorithm with a quadratic time. So that's how you can analyze your algorithms and their time complexity, and similarly their space complexity. Okay, So this was just a preview of the subject. So much more is coming up, including many different approaches to design different algorithms, starting from the brute force, divide and conquer, dynamic programming, and much more, different data structures. Okay. So above all, this whole thing is so exciting. So stay tuned. Never miss out any of the lecture. And I'll see you in the very first lecture of this subject. Till then, I would say goodbye. Thank you.